with Christmas on its way, I noticed that a lot of the Christmas lighting is coming into the shops, and I've always been quite interested in these sort of Luminara style flickering flame candles, which actually use an actual plastic flame that wavers about above a magnet with an LED projecting against it, because it produces a very, very convincing effect. And I saw they had sets of the Premier sort of knockoffs, and they had a set of 3. And I thought, well, let's buy them and see how they've changed, because it's interesting to see how they've evolved over time. Now, the last one I bought was this one, and it was using the original construction of the plastic tube up the middle, just to actually, the different heights of candles to just have a different length of plastic tube to support the electronics, and everything's just glued together. But they'd moved the circuit board from down here up to a combined circuit board with the microcontroller and everything on the actual flame assembly itself, with the little coil mounted directly on the circuit board, which was a neat move. And this has the timer function that if you turn it on, it stays on for, I can't remember, is it 6 hours on, 18 hours off? I think it's something like that, which is quite useful. You can either just turn it on continuously, or have it in the timer mode where it'll turn on the same time every night. And that required this little quartz crystal to run to give an accurate timing reference to the microcontroller. The new ones are notable because, for a couple of reasons. Firstly, with this type, the way to get it out, because they glued it round the base with a sort of gooey, sticky glue into an actual wax housing. And they just sort of pushed it in with the glue on, lined that up and just pressed it in. And to get it out, you could use a bit of pipe against this lip, and it used just gentle force down that would gradually push this out the wax housing. I tried that with these ones, and it didn't go to plan. I'll just turn that one off because it may make some noise. It didn't go to plan. There was a loud scrunching noise and lots of bits of wax and bits of glue, and it turns out that this is the new way they're doing it. They've got this separate flame module that they put some glue around the top, and they just glue it into the top of the candle. And then there's a couple of wires connecting to the battery pack on the base, and going by the length of it compared to the other candles, it's just the same assembly in every single candle, that they just scrunch the wire up inside for the shorter candles, which makes sense. It just means one assembly for them all. I'll move these ones out of the way, in fact. They have the AAA, set of AAA cells in the bottom. Now, another thing with the first version was it used a little switching converter. Did it use a switch converter? Or yes, I'm pretty sure some of them, they did. And the second version, it just used the little voltage regulator running off 3 cells, because the first one's just used 2 cells, and it boosted the voltage up, and that wasn't an ideal situation. The later ones used the 3 cells and the 3.3 volt regulator, and this has gone one step simpler, because this doesn't have the timing, it doesn't have crystals or anything like that, it doesn't have a microcontroller, it just has a little blob chip. And I'll take this out, I'll move these things out of the way. But this one does have some interesting features. It's very much the direction it's going for, just mass production and keeping it as cheap as possible. So this circuit board is looking very bare. I'll actually just turn this off now. It's looking very bare because it's got the coil, it's got a little chip on board, a little black plastic blob, and it's got 2 resistors and 1 diode. So I'll show you the circuit for this. The 3 AA cells are switched through a switch, that's the positive side, giving approximately 4.5 volts. It's worth mentioning, by the way, that it draws about 20 milliamps at 4.5 volts, which is very good. That's pretty much just the LEDs drawing the bulk of the current. And as the voltage goes down, at 4 volts it draws 15 milliamps, about 3.5, which would be round about the voltage, say 3.6 then, of 3 nickel metal hydrides. It's still drawing about 10 milliamps. So this will run quite happily on the rechargeable cells. And if you keep reducing the voltage further, the LED goes out round about 2.5 volts, just because that's the typical forward voltage of a white LED. And then, you know, the movement continues right down to 2 volts from this little coil being pulsed, and it stops. You know, it gradually reduces at that point to the point it's just a tiny little pulse, and it stops around about 1.4 volts. So that chip runs down to quite a low voltage. Now, so we've got the batteries here through the switch, the 75 ohm resistor and the LED. That's simple enough. Then we got a 100 ohm resistor and a diode, presumably just for polarity protection, and then a capacitor, and then the mystery chip that pulses the coil. And I initially thought, I saw the resistor there charge the capacitor, and I wondered if initially the chip might be one of those ones in the swinging pendulum ornaments. You know, the things like the sort of little solar-powered nodding dolls, or like the cat with its paw that waves backwards and forwards, the sort of typical Chinesey type ornament type things. And they normally have 2 triggers. One is that either the capacitor charging up to the high voltage where it will actually trigger the coil, or charging up to the point that it's just about to trigger, and then it's got an amplifier in the coil itself that when the magnet passes over it trips it. So I thought maybe that's what that is. But I noticed it was a very rhythmic pulsing, and it didn't seem to change much with the voltage. So just to work out what that was, I wondered if it was just a continuous pulse. And I found the M34 series 3-pin chip, which is a flasher chip. It's just normally supplied in a TO92 package. And it said it's 1 Hertz. It's available actually 1, 2, 4 and 8 Hertz LED flashing function with a 1 in 8 duty cycle. And it's really simple. It really is just the power plus the LED, and it can drive quite a few LEDs. So I thought, well, it can obviously drive a coil as well. So to see if it was 1 in 8, I cracked out the, I'll just put this out of the way, digital storage oscilloscope, and scoped both the capacitor. The capacitor is the yellow trace here, and I scoped the coil. Now you can see it's the coil because it's got quite a sharp transient when it turns on. And it's the timing for a start is 1 in 5, it's not 1 in 8, so it's similar, but you know, it's not that chip, that specific chip. But it is obviously some sort of pulsar that just goes 1 in 5, and it's nothing to do with the charging of the capacitor, because it just recovers straight away. So I'm guessing that's mainly the reason for the resistor and the diode, is just to basically limit maybe dipping of the LED, when just so you know it limits the current into the capacitor to charge it up, and then the circuit, when it switches the coil on, it will just dump that capacitor a little bit, because the voltage does drop in the capacitor, and that will give it a wee kickstart, but it doesn't go down that far, and then it will rely on the resistor there limiting the current. So it's an odd arrangement, but yes, but yeah, they're definitely quite interesting little things. The fact it's a rhythmic pulsing at 1 speed means it does kind of settle into a pattern. But I did notice that as the voltage goes down, it hits resonant frequencies with the LED, and you get a different, the pattern slowly changes over time. And certainly as the voltage goes down, it's still lit quite happily when it's drawing only 5 milliamps. So this is one of these situations that instead of going down to just a small bit below the battery voltage and then sort of struggling and cutting out, like some of the older microcontroller ones used to really pulse the LED, and they used to drain the batteries very quickly. These ones are just going to just gradually fade away until you decide to change the cells. But at the end, you know, you'd still see them glowing, but they wouldn't be that bright, but they'd still be moving. So it's an interesting, it's the next evolution of these candles, is the fact that it is dividing into the super simple modules like this. It's a neat arrangement. Well, after I'd recorded that first section of the video, I suddenly realised I didn't finish taking it to bits. Let's go the rest of the way. So the actual housing with the LED and the flame itself, which is the coil pulses through the plastic base, it comes out like this, I'm not sure why they've got the two separate sections like that, unless it is just the fact that this bit parts. So if I clip it into that, then they can screw the circuit board up against it. It's probably just for ease of manufacture. But when this is parted, it reveals another interesting feature. There's the wire and the counterweight for the flame, and as you can see, it's just a wire with a dip in it to make the flame align at a very specific distance from the LED. And it's quite a deep dip, I have to say, compared to some others. But what's really interesting is this LED. It's quite a largish LED, and it's very tightly focused. It's really accurate. Look at the size of the dot it projects. It's very, very narrow beam. It's a nice colour too. It's the proper rich candly colour. But I'm guessing the reason for that, it doesn't even try and light the whole flame. It just lights a small dot on it. And as a result, that gives more of a sort of wavering, flickering effect as the sort of beam moves up and down. It's actually quite a good effect, although it does project a much smaller amount of light on the flame than some of the others do. Also, because the dot is quite small, it rarely goes past the flame onto the wall. Some of the other units tended to splash light out everywhere, and you'd basically see a silhouette of the flame against the wall. So I wonder if they've had these LEDs custom. You know, they've maybe got an existing narrow design, got the rich warm candle colour put in, or if it's completely custom designed just for that task, with quite a large lip round there to go into the plastic housing. There's a possibility that it is a custom LED just for that task, which is interesting. So yeah, it's an interesting step forward. I don't see it going a huge distance further, because this is pretty much as minimum as they could go, as minimalist. It's quite neat. It's quite neat indeed.